Hello everyone. Today we're going to learn a few new concepts. I will need you to take notes on your notebook. This is a typical atom model. And in the middle, you can see there are three positive particles. Those are protons. And there are four green ones. Those are neutrons, has no charge. And those blue ones are electrons, negative charged. A typical atom contains the same number of protons as the number of electrons. Okay, so the positive and negative can cancel out. And one more thing is Niels Bohr proposed the electron energy levels. He said different electrons can be in different energy levels. So you may notice that for this first circle, first energy level, there are only 2 electrons. And then this one went to the second energy level. Okay, so if you have any experience with magnets, you know positive and positive or negative and negative, the same charge, they don't like each other, they repel. Okay, the electrons basically also repel each other. That's why they go to different energy levels. Okay, so here's the rule for filling up electrons in different energy levels. The first energy level can only host 2 electrons, the maximum. And the second energy level can host 8 electrons. That's the maximum. When it's full, it cannot hold any more. When there are more electrons, it would go to the third energy level. Again, the third energy level can hold 8, the maximum. This is the rule for filling up electrons. And please write this down on your notebook. I always use the example of parking lots to explain this. Think about there are 3 floors, okay, 3 floors of parking lots. People prefer to park in the first level. But the first level can only host 2 electrons, 2 cars, okay? When it's full, you have to go to the second level. You go up to another level, and this level only have 8 parking lots. And again, people prefer to park at here. And when it's full, you have to go to the third energy level. The third floor only have 8 parking lots too. So first, go to the lowest energy level. And when it's full, you go to the second one. When it's full, you go to the third one. And there's 2, 8, 8. That's the rule. Okay. So for example, hydrogen is the number 1 element in the periodic table. It has 1 proton, also 1 electron. That's how it fill up the energy levels. It fill the first energy level. Okay. Helium is the number 2 element. It has 2 protons and 2 electrons. So this first energy level can hold 2 electrons. So we normally draw them separately because they repel each other. Okay, so now we have lithium. Lithium is number 3 in the periodic table, means it has 3 protons and 3 electrons. The first energy level can only host to the maximum, so you have to put the other one in the second energy level. Okay, so now we have fluorine, which is number 9 in the periodic table, means it contains 9 protons and 9 electrons. So what we do is we put the first 2 in the first energy level. So after we have 1, 2, and then 3, 4, 5, 6, 7, 8, and 9. Okay, so totally 9, you put 2 in the first energy level and 7 in the second energy level. Okay, then how about neon? Neon have 10 electrons. It's number 10 in the periodic table. 10 protons, 10 electrons. The first 2 go to the first energy level, and you have 8 left. All of this can fill into the second energy level. That's how a neon atom look like. And after neon in the periodic table, there is sodium. So for sodium, it's number 11. Means it has 11 protons and 11 electrons. So the first energy level can host 2. The second one can host 8. And when we have 2 and 8, that gave us 10. So sodium has 11. It has 1 extra. What happened is this one have to go to the third energy level. So it looks like this. Okay, so we are going to practice, okay? So lithium has 3. First 2 go to the first energy level, and then the next one go to the second energy level. Fluorine have 9. So again, the first 2 go to the first energy level, and the rest of them, 7 of them, go to the second energy level. Okay, when we draw it on a piece of paper, we normally use black dots. Just use your pencil to just use dots to represent the electrons. Okay, and we normally spread them out because even though they're in the same energy level, when we draw them, we spread them out because they are all negative. They repel each other. Okay, so here's a new concept I need you to write on your notebook. Okay, and we gave a name of the electrons in the most outer energy level. We call them valence electrons. Valence electrons are the electrons in the most outer energy level. Okay, so for example, lithium has 2 in the first energy level and 1 in the second energy level. The second energy level basically is the most outer energy level for lithium. It has 1 in there, so we call lithium has 1 valence electron. And for fluorine, it has 9 electrons. The first 2 goes to the first 2 go to the first energy level, and then we have 7 left in the second energy level. Again, for fluorine, the second energy level is the most outer energy level. It has 7 in there, so we say fluorine has 7 valence electrons. That's how we determine it. Okay, we are going to learn more about valence electrons. Right now, you just need to know the concept. When we learn the detail of periodic table, we are going to figure out more detail of this. Okay, right now, just know the concept is fine. Okay. My computer just keep on freezing. Okay, so one more thing today is I'm going to introduce you a new word. This is the octopus. Octopus have 8 legs. We call it octopus. Okay, and in math, I'm so sorry. My computer just keep on doing this. Okay, there's octagon when there's 8 sides, right? We actually call this mom. She got 8 babies at once, so we call her octomom. Okay, octa means 8. And in chemistry, there is a word with octa. It's called octet rule. Okay, octet rule. What does it mean? Is every atom wants to have 4 valence electrons. Normally it's 8. Okay, in its outer energy level means it really want to fill up the whole shell. Okay, the first energy level can hold 2. So for the first few atoms in the periodic table, like hydrogen, helium, lithium, and a few more after lithium, they would have 2 only, okay, because they don't have that many. But for the rest of them, they would just want to have 8 valence electrons to fill up their most outer energy level. Okay, what do they do to get, for example, lithium has 3, right? Lithium has 2 over here and 1 over here. It's want to have 4 valence electron, and lithium would just prefer to give away this one. And for fluorine, it has 2 over here and 7 in the second energy level. It has 1 more. It needs 1 more to be 8. So fluorine would normally just gain 1 from other atom. Okay, we're going to learn this next semester when we learn about chemical bonding. Right now, I'm just introducing you the concept. So when we learn about new information, you don't feel like surprised. Okay, right now, just the concept. For octet rule means we want to have 4 valence electrons. It could be 2 or 8. Okay, normally it's 8. Most of them they want 8. The 2 is just for the first few atoms because they don't have many. They don't have a lot. Okay, so the last concept again I need you to write on your notebook is called an ion. What does it mean by an ion? An ion is still an atom, but it has charge. An ion is a charged atom which is formed by gaining or losing electrons. As we said, they all want to have 4 valence electrons. How do they get 4 valence electrons? They have to either give away some electron or gain some electron from other atoms. So we call those a charged atom. Okay, for example, lithium has 3 electrons. It has 2 in the first energy level and only 1 in the second energy level. So lithium would prefer to give away this one. Okay, once it gave away one, it has 2 left. So the difference between lithium atom itself and the lithium ion is the charge. Okay, if you remember, we have been saying that the number of protons equal to the number of electrons, so they cancel out each other for a neutral atom. For normally for an atom, it contains exactly the same number of protons and the electrons. So for lithium, it has 3 protons, 3 positive, and 3 electrons, 3 negative. So 3 positive and 3 negative cancel out. So the net charge of lithium atom is 0. But when lithium gave away an electron, lithium is still lithium. Okay, the number of protons would never change. So lithium still has 3 protons, but at this time it has 2 electrons left. Okay, so we have 3 positive and 2 negative. The net charge would be 1 extra proton. So 2 electron, 2 proton will cancel out, and you have 1 positive left. So the net charge would be +1. We would call this lithium ion. Lithium ion's charge is +1. So again, right now we are just getting to know the concept. So when we really going to do those ions and chemical bonding for quarter 3, you don't feel surprised. Okay, please write this down on your notebook. And sorry for lots of notes today. I hope you have learned something new. And we are going to do a simulation during the live class, so it will help you to understand the concept better. Okay, thank you.